Hello, everyone. Good afternoon, dear authors and invited guests. Welcome to Technical Session 5C. Myself, Karthik Bharadwaj, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Solistic LLP, it's my great pleasure to welcome you to the 9th International Conference on Information and Communication Technology for Competitive Strategies, ICTTS 2024, Jaipur, India. The ninth edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in Jaipur, India, and the virtual event is being held through Zoom today and tomorrow, that is 20th and 21st December 2024. I hope you will find the session knowledgeable and interactive throughout the day. In this session, we have 10 presentations. Each presenter will be given 8 minutes for their presentation and 2 minutes for question answer. On 7 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us to the closing remark. If you have any query or update, you can write it to me in the chat box. Just before we get started with the session, I would like to introduce you with today's session chair, Professor Amar Bukhet. He is currently an associate professor at Vishwakarma Institute of Information Technology, Pune. Earlier, he had worked at Pune Institute of Computer Technology, Pune, and MIT ADT School of Computing. He has 18 plus years of teaching experience. His main area of research are distributed system, cloud computing, distributed system security, computer networks, Internet of Things, blockchain. I request sir to kindly address our participants.
Thank you, Karthik sir, for nice introduction. I hope I am audible now.
Yes, sir, you're audible to us.
Okay, so it's a good opportunity to authors to present this paper to this ICTCS 2024 conference. I wish best wishes for the authors. Thank you very much.
Thank you, sir, for such kind and motivated words. Now we are starting with the first paper of the session. For the first paper, I would like to call the presenter Ravi Kumar Patel for the paper title, A Comprehensive Survey on Text to Video Generation, Models, Architectures, and Challenges. I request participants to kindly proceed with their presentation.
Hello everyone, am I audible?
Yes, sir, you're audible to us.
My screen is visible?
Yes, sir, your screen is visible to us.
Good afternoon everyone, myself Ravi Patel and I am from Charoswati University. Today I'm going to present a comprehensive survey on text to video generation which provides the model's architectures and the limitations that already authors have identified. Okay, so text to video generation is like based on textual description, it will provide a video models. Okay, so there are the very few researches have been done on text to video generation. Okay, there have been many researches have been done in text to image generation, but the problem with text to video generation, because it requires a very large data set and it requires high computation costs. Okay, so these are, I'm going to present a particular some of the models to you guys. So okay, I'm going to present our knowledge of models that have been already done by the researchers and architectures and the limitations. Okay, so first model is a diffusion model. Okay, so diffusion model is mainly used for text to image generation, and after the successful generation of the image, it will extend to the text to video generation. So diffusion model is mainly works with the two processes, forward process and the reverse process. Forward process is in which a image is noise is added to the image, and into after that a neural network will be trained to how to remove a noise, and after that for reverse process will be used to remove a noise by steps. Okay, these on a three particular steps, the image based on the textual description it will generate images, but there were a very few limitations, like it required a very high computational cost and the insufficient sampling as compared to the generative adversarial network. The next model is E2HQV model. The E2HQV is a deep learning framework that mainly focuses on the event streams. Okay, it will directly not define any images. Okay, based on event stream, it will generate a video. There are the two main components of the E2HQV, like REFE module and then TSEME module. So based on the event stream, it will identify main features of the images, and after that it will and after that it reset a state reset problem, which is a major problem into the consistencies between the frames. After that, the temporal shift embedding, it provides a consistencies between the frames. And the third phase of this model, it generates a multiple frames based on the information that are uh, gained into the input module. Okay, so there are the few advantages, like high compute it used for the high quality video generation, and the major component that E2HQV is resolved is handling state and reset issues. Okay, and the another major problems like E2HQV face that it requires a high computational model, and the and a state reset is also the one of the major problems of the E2HQV model. Okay, so next model is a gain model, and the variance of the gain is ENC gen module. The main three components of the gen modules is encoder, discriminators, and the generator. Okay, so encoder is mainly used for extract the information from the particular video frames. There are the two encoders that researcher is used. First is a motion encoder and the content encoder. Okay, the information of the encoder is given to the generator, and generator will generate a three different frames: content stream frames, motion frame, and the video reconstruction frame. And after that, a discriminators will discriminate a original image and the image that is generated by the modules. Okay, so these are the working of the ENC gen. But the major problems of the generative adversarial model is a training complexity. Okay, it is heavily defined. It is like computational cost and the dependency on the latent code. If the latent code does not provide the correct information, then it will not define a correct output video frames. Okay, the next is clip embedding model. The clip embedding model is mainly works on the two encoders, text encoder and the image encoder. A text encoder will extract the information, and image encoder will match with the text and the image. For that, zero shot classification is used, which is mainly works on the cosine severity matrix. Okay, so based on the text and the images, it will produce a video frames based on clip embedding. Okay, but the major problem with the clip embedding, it struggles with the complex scene. So clip embedding cannot be used for the real-time scenarios. And the next module is streaming T2V modules, which is mainly works on the three stage: initialization stage, streaming T2V stage, and the refinement stage. In a first stage, a pre-trained text to video model will be used. As an input, a textual description and a noise is given to the pre-trained text to video model. The researcher is use a video LDM as a pre-trained text to video model. So after output of the one initialization stage, it will generate a 16 frames. So based on that 16 frame, it will divide it into the 8 frames and the 8 frames. So 8 frames is given to the conditional attention module, and next 8 frames is given to the appearance preservation module. So first 8 frame, based on the first 8 frame, a conditional attention module will generate a concurrent frame based on the output of the previous frame. Okay, and then within 8 frames, one frame is selected by the anchor frame, and this anchor frame will generate a concurrent frame. After the output of the streaming T2V second phase, it will combine all the frames that are generated by the CAM phase and the APM phase. And after the last frame, it provides a consistencies to the frames that is generated by the above stage. Okay, the limitations of the streaming T2V, like it is heavily depend on the pre-trained text to video model, which is a video LDM model. If a model will not generate images, then video would be not appreciated by the models. Okay, the next model is a sparse CTRL model, which is similar to the diffusion model, but the major components that sparse CTRL module is used is a sparse encoder and a zero field frames. Okay, zero field frames is used for the consistencies between the two frames, which is diffusion model is not provided. Okay, so but the major problem of the sparse CTRL model is it is not used in a real-time application. Okay, if a complex scene is present, then sparse CTRL model cannot handle that scene. And the next model is image and model, which is work on 8 modules. Like first is a base module, 3 TSR module, and 3 SSR modules. So based on the textual description, it will given to the T5XSL module. So it will generate a first few video frames, and this few video frames is given to the base module, which is like generate a video which is very low resolution. And after the low resolution, it is given to the SSR module, which is converted this video into the higher resolution. And after that, the last stage is temporal super resolution, which is provided to the FPS to the frames. Okay, and the major problem with the image and is like it is heavily not used for the real-time application. So these are the modules that I've already done into the paper. Cog video, which is a model, this is used for text to video generation. Then Govida, Frankie, and Tuna video model, and Mokogen model. The applications of the text to video model is we can use a text to video model into the entertainment field, the education field, tourism field, and marketing field. Thank you, guys.
Thank you, sir. Now I request session chair, sir. Sir, do you have any questions? Okay, sir is not having any questions. So let's move towards the next presentation. For the next presentation, I would like to call Rao.
1 second. I want to ask question.
Yes.
Okay, have you got through accuracy of the algorithms you study, Patel sir?
Sorry, sir.
Accuracy of the algorithms you have studied. This seems to be a survey paper.
Yes, sir.
So which one is efficient?
So, sir, I am going to like I have done already. I have to do a research on streaming T2V module, which is used for the text to video generation. Okay, so this is the streaming T2V module is like it will generate a high quality of the video with the 720 pixels. So, yeah, the better quality which provides is streaming T2V module.
Oh, thank you very much. Next, please.
Thank you, sir. Now we are moving towards the next presentation. For the next presentation, I would like to call the presenter Rawat Ramesh for the paper title Enhancing Healthcare Privacy, a Synergistic Approach with Federated Learning and Blockchain Integration. I request the presenter to kindly proceed with their presentation. I think so, sir is facing some network issue. Let's move on towards the next presentation of the day. For the next presentation, I would like to call Martin H. Molle for the paper title Green Logistics in the Digital Era Advancing Sustainability in Global Supply Chains. I request the presenter to kindly proceed with their presentation.
Is my screen visible?
Yes, sir, your screen is visible to us.
Okay, I'm Martin H. Mole from Data Medi Higher Education, Institute of Higher Education and Research, School of Allied Science, I mean. Today, I'll be presenting on the topic Green Logistics in Digital Era, Advancing Sustainability in Global Supply Chain. And so, sorry for that. Okay, this is our content. So, today, this is the introduction. Due to the increase of environmental concern and demand for sustainable business practices, green logistics has become essential to supply chain operation and modern logistics. So, logistics in supply chain management also includes methods to reduce environmental impact through effective product recycling and forecasting. Uh, and also, it has some needs that can be determined, whether to return to prediction can be determined precisely at the individual continuum level, thereby leading consistency in forecasting agreements. So class formation has also been an essential part of the new concentration, which has thrown emphasis on sustainable development and infrastructure that serve the need for the present without preventing perspective for the future generation to meet their own needs as well. So this is a research methodology, and this particular methodology is based on uh, secondary data analysis, which have the systematic ongoing through relevant past studies, reports, and publication. This method has several advantages. It enabled me to understand existing concepts, reveal patterns that are now in place, and draft insightful information without gathering new data. In addition to that, it also allows one to evaluate the status of sustainability initiatives in the supply chain and logistic sectors without incurring much cost and by using readily available data. So, to understand the concept of sustainability in supply chain management, when the first green supply chain was introduced in 1989, the fee to create an ideal forecasting method that businesses could use to predict products that might be recycled. However, the return of individual containers is really predicted with precision, making this forecasting system very controversial and partially potentially leading to inconsistent results. So sustainability has been a crucial thing that have been integrated in business operation and supply chain network, and also have a growing and developing needs today without having any ability of future generation and meeting their needs as well. This involves managing flow of material, information, and money. So this particular concept of sustainability have three main things that we'll be focusing on. One, economic; two, uh, environmental; and three, social. So we're going to see in the next slide. So uh, the definition of sustainable logistic and supply chain states that sustainable logistics is an evolving fact in a world of contemporary supply chain and transporting management, focusing on social responsibility, environmental sustainability, and long-term economic viability. It is called about implementing initiatives that are meant to cut down the ecological footprint, and research papers has explained supply chain as one of the most used definitions in aligning businesses with customers or consumers to deliver items. So this is the traditional view of supply chain with, with products moving from supplier to processor, from wholesaler to retailer, and finally the consumer, the one that will consume the product after all. So, importance of sustainable logistics and supply chain. Supply chain, it has described the capacity to predict, adapt, and recover the setbacks, and it is necessary to guarantee the operation continue to run smoothly. And also, it interplay the structural and dynamic component to facilitate a seamless transition from innovation and resilient in green innovation by significantly enhancing resilience to setback. It helped the supply chain to raise ethical and environmental issues. The goal of sustainable logistics and supply chain is to reduce the consumption of resources and carbon emission to and change societal norms on sourcing and production. So these are factors that are influencing sustainability. environmental factor, social factor, economic factor, and technological factor. Also, we have standard and regulatory factors as well. So the environmental factor have to do with the concern that sustainability have to do, especially when it comes to logistical materials. In transporting those materials, companies need to observe the environmental factor as well, so that they cannot pollute the environment, because organisms and other people are also part of that particular environment. So companies should also observe this particular aspect. When it comes to social factor, the idea of social sustainability is in supply chain or management pertains the management of social issues both upstream and downstream for leading businesses. This means that it extends beyond internal operation and includes suppliers, stakeholders, and local
Sorry
communities.
to interrupt, sir, but you have 1 minute to conclude.
Okay, so economic factor as well. We have economic factors and also technological advancement and ethical standards. We can talk about this particular sustainability without involving regulatory and standards as well. So companies need to also focus on regulation so that they can be transparent. In conclusion, this research claims that in light of the content, environmental and social problems associated with conventional as opposed to traditional supply chain management is crucial to address. Sustainable logistics embraces an array of essential factors, including sustainability drivers related to social responsibility, economic viability, and environmental concern, as well as technical breakthroughs. So these are my references. Thank you.
Thank you, sir.
Any implementations for CO2 emissions have been done?
Sorry?
Hello.
Yes, hello?
For green energy, any implementations of CO2 emissions whether have been done?
Uh, for green energy, like companies or any organization can implement, can lead to like using of solar panel or using hydro power, so that the environment can be clean, to avoid carbon footprint, to avoid carbon monoxide spraying in the air.
Okay, thank you very much.
Thank you, sir.
Thank you, sir. Now we are moving towards the next presentation. For the next presentation, I would like to call Praveen Kumar for the paper title Implementing Non-Functional Production Regression Testing with Kubernetes. I request the presenter to kindly proceed with their presentation.
Thank you, Karthik sir, for giving me this opportunity. Let me share my screen.
Thank you, sir.
Let me know if you are able to see my screen.
Yes, sir. We are able to see your screen.
Thank you. Thank you. So today I'm going to present implementing non-functional production regression testing with Kubernetes. I'm the one of the other Praveen Kumar Maroju, and also I have two more, Venu Madhav Regani and Lakshmi Narasimharaju Mudunuri. With the help of this, we did this research, and today I'm going to present on this from next abstract. Sorry. So actually, this study examines how the adoption of DevOps practices and microservices architecture shifts the responsibility for maintenance from operation teams to developers, who are now tasked with managing both their code and its dependencies. Although containerization technologies facilitate this transition, a significant limitation persists in the continuous delivery pipeline, which typically supports developers only until deployment. To overcome this challenge, non-functional production regression testing is introduced as an extension of the pipeline into the production environment. So NPRT, that is like non-functional production regression testing, automates the deployment of a new version canary alongside a stable version, monitoring and comparing their performance and executing an automatic rollback in the event of a detected regression. We implemented NPRT within Kubernetes by developing deployer that integrates continuous integration systems with monitoring frameworks for Kubernetes clusters. The effectiveness of the NPRT was evaluated through real-world applications, including an Apache middleware and a Rails application, ensuring continuous automated testing and improved production reliability. That's the abstract of this study, and introduction is like, sorry. This non-functional production regression testing a practice designed to address the growing burden maintenance work in DevOps environment. NPR to extend the continuous delivery pipeline to automate continuous testing of non-functional challenges in production environment. So, automate testing of non-functional changes in production environment to reduce maintenance efforts in DevOps. It automates key tasks of NPRT is like it automates rapid deployment, low risk monitoring, and automatic rollback of changes, reducing the need for manual intervention. And it also implemented using the deploy tool, integrating CD pipelines with Kubernetes to streamline maintenance automation. Evaluation is like was successfully tested in real world settings, showing improvements in software reliability and automated maintenance processes. And also it fills the gap in fully automating maintenance, ensuring continuous testing, reducing risk and preventing technical debt buildup. Next. And our related works is like in production environment is an increasingly critical practice for organizations, particularly those managing complex systems, to ensure that software performs reliably under real world conditions. Various methodologies, tools and systems have been developed and implemented. So gradual rollouts, Facebook uses Gatekeeper for controlled feature deployments, gradual activating features across user traffic levels to ensure smooth transition and minimizing risk. And this methods simulates user behavior in production environments, helping detect issues in complex systems with interdependencies as seen in microservices. And chaos engineering is like Netflix Simian Army introduces controlled failure in production to identify unknown vulnerabilities and enhance system resilience. And deployer versus other tools like deployer is a lightweight, simple tool focused on fast deployment automation, contrasting with more complex solutions like Spinner and WAMP that require external infrastructure. Metric analysis. So effective monitoring tools such as Datadog and Prometheus are essential for production environments with advanced metric analysis. And pre-implementations is an advanced approach designed to evaluate non-functional changes in software by deploying them in production environment, as shown in the picture actually, that you can see it later. The innovation of NPRT lies in its ability to run a new version of software alongside the stable version within the production environment. So facilitating real-time monitoring and automated rollback in the event of detected regression. And also in the enables its real-time monitoring of performance metrics and automatical rollback changes, and also enhances traditional CI/CD processes by creating a fully automated feedback loop that continues monitoring post-deployment, giving developer more control. Fail fast principle. So NPRT focuses on identifying issues early in deployment, ensuring fast detection of performance problems and minimizing risk in production. So in the developer empowerment, by shifting post-deployment responsibility to developers, it allows them manage production updates, patches, and dependencies changes with a greater efficiency. And NPRT pipeline overview. This will give the commences with the developer implementing a code change locally, which is subsequently pushed to the version control system. The version control system generates a reference for the new version, which is then passed to the CI system. The CI system is building the application, running test, and signaling the deployer service for deployment. The deploy service deploys both stable and new versions in production using Kubernetes, exposing the canary version to limited traffic to reduce potential risk from regressions. And NPRT collects and compares key performance metrics, that is latency, error rate, resource utilization. Those are the examples. For both versions, using SRE principles to monitor stability. Automated rollback. If any performance regressions are detected in the canary version, the system automatically triggers a rollback, reverting to the stable version to ensure continuity. If no regressions are found after a set period, the canary version is promoted to stable, completing the deployment, ensuring reliable software updates. In the post implementations, it is to streamline the deployment process by automating the management of Kubernetes resources. Notably, deployer supports canary deployments, allowing new application versions to run concurrently with stable ones. And deployers rule in Kubernetes, it will give the stableness and seamless CI/CD integration. Also integrates with tools like Datadog for real-time metric monitoring and offers a simple HTTP interface, making it compatible with CI systems and accessible via command line tools like DEPCTL for optimized workflows. And also deployer validates client requests, retrieves the correct version using a commit hash or revision number, and modifies Kubernetes resource definitions before sending them to Kubernetes API for rolling updates. And also deployments, deployer creates a canary version with fewer replicas, distinguishing metrics between stable and canary versions to track performance. Metrics include CPU, memory usage, latency, and error rates, ensuring accurate comparison. Automated feedback and rollbacks. If metrics collected during canary deployment deviate beyond acceptable thresholds, the monitoring system triggers alarms, allowing for automated rollback to maintain stability. Deployer promptly notifies developers of errors via reporting system. It's the experimental analysis. Uh, we discuss about a detailed overview of experiments conducted on two production applications to evaluate the performance, deployment, rollback capabilities of a canary deployment system using the deployer in Kubernetes. Also, in the web server, had a much faster deployment time compared to Gapfish Ruby on Rails application. DN's deployment took between 9 and 12 seconds, while Gapfish deployment ranged from 65 to 106 seconds. The difference was mainly due to the Rails application startup time. And rollbacks were faster than deployment for both applications. Din's Apache system rolled back in 4 to 5 seconds, whereas Gapfish Ruby on Rails took 63 seconds due to slow pod shutdown times. Impact of caching. Deployer's caching mechanism reduced deployment times for Gapfish Ruby on Rails application significantly in subsequent deployments. However, it had minimal effect on Dian's Apache web server due to its smaller repository size. And CI/CD pipeline efficiency is like for Gapfish application, the total time from committing a change to deploying a canary version took between 172 and 414 seconds. Caching within the CI system and Docker image registry reduced deployment times with a median of around 3 minutes per process. This study demonstrated that using promote production metrics
Sorry
for
to
automation.
interrupt, sir, but you have 1 minute to conclude.
Okay. Yeah, these are the execution timeline that you can see. So DI and Apache middleware, Gapfish Rails application server, performance on deploy pipeline, and conclusion. I will want to jump to conclusion. It's like a responsibility resulting from the adoption of DevOps and microservices, which places an increased workload on developers due to the flexibility of microservices and the multitudes of dependencies. NBRT extend the CD pipeline by automating regression, test in production environments, leveraging the deployer tool to facilitate canary deployments and metric comparisons. And also increased workload placed on the developers due to the complexity of microservices. DevOps practices by automating key maintenance tasks like regression testing, canary deployments, and rollbacks. And this experiments with the DINS Apache web server and Gapfish Ruby on Rails application demonstrated NPRT scalability and effectiveness in handling real-world Kubernetes environment, reinforcing its utility for diverse applications. Future enhancements and automation. This will improvement include using traffic cloning with the Gore Play for safer testing, enhancing instrumentation, and automating updates for Docker images and dependencies, further streamlining software maintenance processes. And these are the references which we referred during our experiment. And Thank you. Do you have any questions?
Okay, what are the parameters you have taken for analysis?
As we mentioned, like throughput, there are the examples were given in one of the right. So some CPU, memory, and throughput and the capacity
Okay,
are the
have you done
parameters.
comparative analysis with other algorithms?
We do not have any other pipeline which allows the non-functional product regression testing, because we have functional regression testing. We do not have non-functional regression testing parameters. That is the reason we couldn't provide you the comparison. But this will give you that this is the first time which we are doing the non-functional regression testing. This will give you the decent results that we can proceed further on this.
Okay, thank you very much. Good work.
Thank you. Thank you.
Thank you, sir.
Thank you.
Thank you, sir. Now we are moving towards the next presentation. For the next presentation, I would like to call Pratha Anande for the paper title Machine Learning for Monitoring Wind Turbines. I request the presenter to kindly proceed with their presentation.
Thank you. I hope you can see my screen. Is the screen visible?
Yes, ma'am. Now it is visible to us.
All right, thank you. Okay. Then proceeding with our topic. So a very good afternoon to everyone present. My name is Prathan Nagate, and me, along with my teammate Isha, will be presenting on the topic of our research, machine learning for monitoring wind turbines. Throughout this entire project, we have been very grateful for the mentorship by Dr. Mangesh Gedekar, who's also here with us today. So talking about what we're going to look at today, we'll take a look at the introduction to our topic with the problem statement. The literature review and the related works will be explained by Isha. We'll talk about the framework utilized in this entire process, along with the mechanical aspect of this project. We'll then talk about the methodology or the scope and limitations. Results will be discussed with the implications of whatever we have understood, and then we'll move on to the Q&A.
Thank you, Pratha. A very good afternoon to everyone present. So I would like to commence this presentation by giving you a brief introduction into our topic. So as we all know, we have a pressing need to address the environmental degradation that our conventional energy resources have been causing yet, whilst the demand for energy keeps on increasing, and there is an imperative need to find a critical balance between those two. One such solution to these problems comes out to be wind energy, which has been used for over 1500 years now for its many promising benefits. Our research explores the importance of reinforcing traditional wind turbine systems with data-driven ML models. So our problem statement is as follows: exploring the application of IoT-driven machine learning models for predictive maintenance of wind turbines, and we have used SCADA data for our experimentation. Our objectives include to employ robust machine learning models for predictive maintenance of wind turbines, also to identify the optimal time for energy production based on wind speed, and generate actionable insights into energy production. Review of literature, related literature. So we conducted an extensive literature review before commencing with our project, and it suggested that this is a trending topic and up and coming topic in today's world, where a lot of industry 4.0 technologies are being integrated into traditional systems. Commonly, we found common areas of research that explored digital twin frameworks and cloud-based frameworks for facilitating failure prediction models in wind turbines. Next slide, please, Pratha. Okay, so looking at the mechanical aspect, so we can divide it into three parts. Firstly, we know that there are two types of wind turbines, a vertical axis one and a horizontal axis one. Due to ease of data, we chose the horizontal axis wind turbine for our experimentation. Then energy conversion aspect, as we know that wind turbines convert kinetic wind energy into mechanical energy and then ultimately into electrical energy, which is used for further processing as required. And in this topic, we have used SCADA system data which is helpful because it is inclusive of mechanical parameters such as wind speed, wind direction, active power output, which in turn influence the turbine's mechanical performance. Over to you, Pritha.
Right. Okay, thank you so much, Isha. So Isha has given us a brief, actually in-depth background of whatever we have done. Moving forward with the machine learning part of it, the framework we utilized included two main models, the random forest regressor and the gradient boosting regressor. The main idea out of all of this was to identify key factors which influence your model and inline it with the objectives we have identified earlier. So the random forest regressor constructs multiple decision trees. Essentially, it's a tree-like structure which is used for predictive modeling, and the leaf node gives you the output. So we have used, instead of just one singular one, we're using a random forest which averages the outputs of multiple decision trees. It reduces overfitting. Overfitting essentially is like your model is highly trained on just the test data. So when you introduce new data to it, it's not going to be very easily identifying the models. The next one we used was a gradient boosting regressor. It, instead of parallelly processing like random forest, we do it sequentially, and it optimizes the errors of the prior models. So talking about this framework in-depth view, this was the methodology utilized. Isha already talked about the data collection. We moved on to data processing, which is like validation, cleaning of your data, normalization, all of that. Then we had the models applied to the pre-processed data. We understood the main features, which would be used later to align to objective number 3, which is to give decisions relating to your environmental sustainability productions. Then we will optimize your recommendations, which we'll be looking at moving further. So before we go to the results, let's talk about the scope and limitations so that future work can take this into consideration. First of all of this is done on one singular data set. However, this is a very valid data set used for multiple different analysis as well. Moving forward, maybe for vertical shaft analysis instead of horizontal, like Isha mentioned, you can look at different data sets. The complexity can be increased by introducing other deep learning methodologies instead of machine learning methodologies. False alarms are very unlikely, but each model has its own pros and cons. So maybe taking into consideration other factors like like cyclones or weather conditions, we can take into consideration false alarms. Talking about the results of our analysis, the chart on left talks about the average energy generation by the hour, and the insights reveal that optimal energy generation is at 8 o'clock. Now, what does this tell us? This tells us that in the morning, when you have the time from, let's say, 5 a.m. to 1 p.m., you can completely shut down generation. That's going to save energy and start generating energy after that, because that's going to give you anyway a higher amount of throughput. Then we have a predictive active power production R square of 97% approximately. And the predictive maintenance has accuracy of 95, which is actually one of the highest in all of the literature review that we have conducted. So this tells us that machine learning plays a very important role in mechanical systems to increase operational efficiency and predictive maintenance. And data-driven insights are very important in Industry 4.0 as we take forward sustainability in renewable energy. So with this, we'd like to conclude. These are just a couple of references we used right now. Our actual methodology consists of much more references as seen in our paper. And we're open to questions now. So if anyone has any questions.
We do not see any latest references, actually.
Sir, if you would like, I could open the paper and it has a bunch of references from 2020 to 24 as well. This is just used in the PPT, not in the entire
Algorithms you shown regression analysis. I do not see any random forest. I do not see any comparison actually among these algorithms. Which one is better?
Okay, sir. So random forest regressor was used for predictive maintenance, and gradient boosting regressor was used for analyzing the optimum hours. So we did not use both of them for all of the tasks.
Okay.
Yes.
Okay, thank you.
Okay, thank you, sir.
Thank you, sir.
Thank you,
Yes.
sir. Thank you, ma'am. Now we are moving towards the next presentation. For the next presentation, I would like to call Jadhani for the paper title Plant Disease Identification System with the Deep Learning Capabilities, a step towards sustainable agriculture. I request the presenter to kindly proceed with their presentation.
Okay, sir. Am I audible?
Yes, sir, you are audible to us.
Okay. Is my screen visible?
Yes, sir, your screen is visible to us.
Good afternoon, everyone. My name is Krunal Jodhani, and I am here to present our research titled Plant Disease Identification System with Deep Learning Capabilities. This work is done with my co-author, Hemit Rana, under the guidance of Dr. Nikita Bhatt at Charusat University. So, why this topic is important? So, plant disease cause major losses to crops, impacting food security. Traditional methods of identifying, just a second. Yeah. Like traditional methods of identifying this disease are slow, expensive, and not always accurate. That's why we developed the solution using deep learning to identify plant disease quickly and accurately. So let's read the problem statement. A farmer struggle to detect plant disease early. Like current method need expert knowledge, take too much time, and cost a lot. So we created a system using ResNet 18, a type of deep learning model to detect plant disease. We also build a web application using Django framework where farmers or users can upload plant images and get instant disease diagnosis. So key benefits of our system is early detection means cost effective and we enhance agriculture sustainability. So objective of our system is to evaluate CNN and ResNet 18 model performance on plant disease detection. We have also compared our model with VGG16 and Inception V3. We also implemented a web-based application for user-friendly disease diagnosis. So this is how CNN work on our system in background. So like when we upload the image, CNN will apply a activation function called ReLU and do a polling. After that, it will classify and give us the result. So we notable model our ResNet 18 we have achieved a 99.8% accuracy in apple leaf disease detection. Where we have also do comparison. So here it is like ResNet 18 will give us 99.8% accuracy, VGG16 will give us 98.1, and Inception V3 will give us 97.4%. So methodology, we have used a ResNet 18 based architecture fine-tuned for plant disease detection. We implemented it on a plant village dataset deployment through a Django server. We use tools like TensorFlow, Matplotlib, and Django. So we use a plant village dataset, which is a dataset of like leaf images of healthy and diseased plant. The plant village dataset contains over 70,000 images covering 38 plant disease, including healthy leaves. Images are split into like 70% for use for training, 15% for validation, and 15% for testing set. Each image represents a 224 by 224 pixel resized, normalized, and augmented RGB image. So for training purpose, we do augmentation techniques like rotation, flipping, and zooming applied to training data. For training configuration, we optimize it using ADAM optimizer, then adjust learning rate dynamically with scheduling over 60 epochs. We also monitor accuracy and loss rate for like real time for training and validation phases. So from that outcome is the model showed high generalized across plant disease categories and improved over successive epochs. So this is the result over 60 epochs. The model, this shows that steady decrease loss and consistent improvement in accuracy over epochs. So this is our result. The model accurately identifies plant disease and healthy leaves with high confidence, except some of cases like northern leaf blight. Results shows like robust performance, highlight the model's potential for early disease detection and crop protection. So we we have some future work also. We are looking for real-time monitoring for dynamic disease detection and expanding data sets for and exploring other architectures, and also do with integration with IoT and for automated monitoring. So let's conclude like paper. The ResNet 18 based system demonstrate high accuracy and potential for real world applications. Future development aims to enhance real-time detection and expand usability and contribute to sustainable agriculture by reducing crop losses and ensuring food security. Thank you.
Yes, for validation testing, right? Your graph suddenly drops. What is the reason?
So, sir, we use like we have do.
Please.
Yes. We have we use early stopping method for like that.
Go to that slide where Shari is asking the question.
Yes, ma'am.
Please. Okay. Your voice seems to be slow. Here, if you see validation accuracy suddenly drops at 6 at x-axis. What is the reason?
So here, sir,
Hello, am I audible?
Yes.
Yes, it is audible because here our model is pre-trained. We have taken the pre-trained model and that model is overfitted. So now we uses this loss that we are getting. So the conclusion of this experiment is our model is overfitted method for the same.
Yeah, thank you very much.
Okay. Thank you, sir, for the question.
Thank you, sir. Thank you, ma'am. Thank you, sir. Now we are moving towards the next presentation of the day. For the next presentation, I would like to call Tanishka Singh for the paper title Safe Trails Accident Prevention on the Blind Turns Using Image Processing. I request the presenter to kindly proceed with their presentation.
Thank you for the opportunity, sir. I hope I'm audible.
Yes, ma'am, you're audible to us.
Hello to the respective judges, and I'm Tanishka Singh, and I'm one of the authors for our paper titled Safe Trails Accident Prevention on Ghat Roads Using Image Processing. So, our paper abstract is presented over here. Our basic idea for the project is to prevent the accidents that are happening on the Ghat roads due to the steep U turns. So the problem definition on what our project revolves around is the U-turns. As you can see here in the image, the vehicles cannot see what is coming from the opposite side of the road on the steep U-turns, and adverse climate conditions on the hilly areas as well, where it is difficult for the drivers to drive correctly, And then the failure of reflecting mirrors. So when we talk about U-turns, the problem arises that reflecting mirrors can be used, but this is not a practical case when it comes to hilly areas, because the mirrors may get damaged, they may get uh, dirty, and also they are not well taken away in the hilly areas. So this was the problem statement. Our methodology for solving this problem was basically using two models of OpenCV and YOLO V8 for object detection and lane detection. What we actually did was we detected the objects from the camera from one side of the road and displayed what is the scenario on the second hand side of the road. It could be displayed on normal LCD screens also, and instead of just displaying the whole video or the camera footage, we use lane detection, and we inform the driver to drive in which particular lane. So these are some libraries that we have used. We have trained a custom data set especially for hilly areas and U-turns, and from different weather conditions and different methods. This model also, with the help of object detection, trains it for vehicles, animals, and debris. So when the model was first trained, it was only for car detection, but we have also trained it for animals, because when we talk about hilly areas, animals could also be on the other side of the road, which are need to be taken care of. Also, landslides type of conditions could be there. So object detection contains every sort of obstructive object which could be present on the road, and we inform the driver driving on the other side of the U-turn about it. For object detection, YOLO V8 model, predictive model was used. It was a pre-trained model, but the data set that we have used, the accuracy that we have achieved from our data set was also pretty formal. So car detection was already over there, and the other detections were also being processed in this project. For lane detection, we used pre-processing, grayscaling, Gaussian measures, and canny edge detections. Edge detections were enough for lane detections to tell the driver that driving in which lane would be safer while taking the U-turn. Also, some of the other methods that we used was host transform. We also went for other methods also, but host transform was already used and was pretty good in giving the predictive answers. We started with video processing also for lane detection in a video file also, to make it going in a CCTV camera format. And the optimization was done for the average detection line segments and distinguishing between the left and the right lanes, and identifying in which particular lane the obstruction or the obstacle is. There are many future scopes for this project also. Many of them have been achieved right now, and we are planning to add them to the paper as well. Integration of a real-time navigation using mapping services. So it actually exists with like Google Maps and etc., where the Google Maps can tell you if there is some accident happening or something like that. But integrating it in our model is also one of our future scopes. Advanced object recognition of road debris, fallen rocks, and landslides, which I have mentioned about, is achieved right now. We have achieved this future scope. Weather adaptability, such as handling fog and heavy rain. The model YOLO V8 is in itself capable of doing it, but we are working on much more on the data set with harsh climate condition type of images and videos. And also a predictive analysis can be taken, and we can inform the drivers from a very past side of the road also to drive safely. So this was from our side. Thank you, and we are open to questions.
I request session chair, sir. Sir, do you have any questions?
Session share. Hello, I do not see any comparisons of the algorithms.
So our project was basically based on using YOLO V8 for object detection. So we have done a lot of literature reviews and what sort of model is right now being most used and which model gives the most accuracy. We have gone through many conference papers also for this, and we landed upon the conclusion that YOLO V8 has been the best from one of those. So we directly used YOLO V8 for our model. So therefore, our project didn't revolve around comparing other models too for this.
Okay, thank you.
Thank you so much, sir.
Thank you, sir. Now we are moving towards the next presentation of the day. For the next presentation, I would like to call Aditi for the paper title Systematic Review on Models Used for Crime Detection Using Prisma Approach. I request the presenter to kindly proceed with their presentation.
Thank you so much, sir.
Ma'am, you can start with your presentation.
Yes. Is my screen visible?
Yes, ma'am, your screen is visible to us.
So good afternoon, everyone. It's a pleasure to be here today. My name is Aditi Ganji, and I'm a final year student at Vidyalankar Institute of Technology, Mumbai. So I would like to thank our mentor, Dr. Suja Jayachandran, for giving us this opportunity. And I'm here to represent my team of co-authors in presenting our work on systematic review on models for crime detection using Prisma. So this is the overview of the presentation. Let's get into the introduction part of it. So basically, in an ever-evolving world, public safety and social order are of utmost importance. Like with the rise of digital technologies and exponential growth, crime detection has evolved. Surveillance cameras generates a vast amount of data, and making manual monitoring becomes inefficient and error-prone. So our review paper explores the cutting edge advancements of the technologies in crime detection, focusing on surveillance camera. It identifies unusual behaviors ranging from thefts and violence and etc. So let us dive into the presentation and look what technologies can be used to improve this. So our methodology for this paper was preferred reporting items for systematic review and meta-analysis, which that is Prisma approach, which ensures transparency and systematic reviews for our paper. So we identified a total of 120 papers in which we screened using the exclusion and inclusion principles. And finally, we got we got papers like 31 papers in which are included in a paper. The inclusion principle included the papers which are published in the year 2006 and 2000, between the year 2006 and 2024, the papers related to crime detection using machine learning and deep learning, and systematic reviews using the Prisma approach. The exclusion principle included the articles, blogs, and unpublished papers were excluded. The papers which lack clarity and the papers which doesn't showed much results. So let's move further. These are some of the graphs. The graph on the left side shows the papers published during the years. The highest number of papers in our review paper, which we considered the highest number of papers, were published in the year 2023. And like beside to that, there is another pie chart which shows the frequency of various models used by the papers used in review paper. So YOLO and RCNN are the two algorithms which are dominating in the frequency of use. And it can be because of the temporal features and spatial features of object detection. So let's move further and look further and see what questions we have to find out. So these were the basic questions we had, and we wanted the answers of these through our review paper. So like what data sets were used, which algorithms outperformed, matrices used, challenges faced by the authors, and the influence of policymaking in law enforcement. Let us further look into each question specifically. The first one is, what specific data sets did the studies utilize and how were they curated? The first, the mostly used data set was the UCF crime detection data sets, which included various 1900 videos of different anomalies, including fights, robberies, violence, harassment, etc. The another one is the image data set that is of 65,000 images of weapons and people. The sources were curated by YouTube and Google Images. Another anomaly analysis dataset was of real world crime scenarios, and the other datasets included weapon detection models, etc., which were used for weapon detection, etc. The another research question 2 was, which ML algorithms consistently outperform others in terms of accuracy and reliability? There were different models which were used, but the models which outperformed others were VGG19, which achieved 100% accuracy in one of the paper because of its feature extraction and crime intention detection. The another one was RCNN and YOLO, as we also seen in the pie chart that these were the two which were highly used in the frequency of use. And these were also good at giving its accuracy, effective in real-time object detection with 93% and 89% accuracy respectively. Another one was 3D RCNN, CNN and 2D LSTM, which achieved an accuracy of 95% accuracy using spatial and temporal variables on the UCF crime dataset, and various models which achieve low accuracy compared to the other one. So another research question was, which evaluation metrics have been applied? As you can see, these are the basic evaluation metrics which we use, like accuracy, precision, recall, area under the curve, false positives and negatives. So these help us understand the model better and improve the accuracy of the system. So another research question was, what challenges have the authors identified? Like, as we are working on surveillance data, so computing the real-time data becomes difficult. The first challenge was that model generalization. Reliance on pre-trained models increases false positives and limits adaptability. Data issues, as surveillance data can have poor image qualities and annotation errors, which can reduce the model performance and effectively reduce the accuracy. Privacy concern. Continuous monitoring of surveillance can raise ethical and privacy issues from the user side. Scalability challenges, hardware limitation, and integrating the system into existing system can be a difficult situation for developing this system. So another research question was, how can the findings of this review influence policy making in law enforcement agency? So existing policies were like, they were already focusing on traditional methods which were limited to tech integration. So if we implement these kind of deep learning algorithms into surveillance data, which can promote deep learning for faster automated surveillance and update policy for data privacy, fairness, and false positive rates, and it can somewhat improve the crime detection problems. So here we are at an end of our presentation. This study actually reviews deep learning models like Net19, faster RCNN, and 3D CNN with LSTM for crime detection. Real-time detection faces challenges like computational demands and false positive. Like, we have came to a conclusion that CNN with LSTM, like combination of these model, can be chosen for its adaptability and capability and reliability, so it can perform really well through our review. So this was it from my side. Thank you so much, sir.
References.
Sir, we have included the references in our research paper.
Okay. Yeah, good work. Only thing is that you should mention the results in the graphical visualization format. Thank you very much.
Okay, sir. Thank you so much.
Thank you, sir. Thank you, ma'am. Now we are moving towards the next presentation of the day. For the next presentation, I would like to call Dana for the paper title transforming food management with smart fridge. I request the presenter to kindly proceed with their presentation.
Thank you. Is my screen available? Is it
Yes,
visible?
ma'am. Your screen is visible to us.
Thank you. Good afternoon. I'm Deena Sabahat, and the research topic for this conference is Transforming Food Management with Smart Fridge. One of the major issues that we face in today's world is food wastage. And the major reason behind this is poor inventory management, forgotten leftovers, and improper storage. And in today's fast-paced world, maintaining a healthy and a balanced diet has become challenging. Therefore, Smart Fridge plays a key role in transforming the way we store, manage, and interact with food, and defines the role of kitchen appliance. The main aim for this project was to design and develop a smart fridge with advanced tech features such as inventory management, organization, keeping track of food present inside the fridge, track of expiry date, etc., while maintaining a user-friendly adaptability. The objective was to design an automated fridge with convenient ingredient access that promotes healthy eating habits and lifestyle that can be easily incorporated into existing refrigerator. This project has immense scope. As the technology advances, so does the scope of the project that is driven by the consumer demand. So in the course of my research, I have conducted a survey asking 8 essential and questions in regards to get a deeper insight to the features that needs to be included in a smart fridge. The majority of respondents do not own a smart fridge or not were aware of the features of the smart fridge. But when inquired regarding the challenges they face in organizing the fridge, majority had responded that they do face organizing the fridge as well as are not aware about the energy consumption of their fridge. Therefore, this survey helped me put into a key concentration into the design consideration that should be in a proposed new smart fridge model. I had also conducted a literature review and read numerous papers in regards to smart fridge, and there were numerous related works in regards to types of inventory management, organization, temperature control, etc. But they only differ in types of expiry date tracking, whether through RFID, barcode scanning, image recognition, or manually inputting into an IoT app. It also differed in regards to the database or the softwares that were being used. This is the new proposed smart fridge where it includes 3 doors. It features 3 doors in order to provide a selective ingredient access where the user can use a specific compartment in order to store the food in order to not reduce the exposure of the entire fridge to the outside air to stabilize the internal temperature and reduce the temperature loss. It will also feature a UI screen in order to get to know what's present inside the fridge and to keep track of the expiry date of the items present inside the fridge. The interior of the door, where each door module will have a camera to get a view of items present inside the fridge. The main features that will be included in the smart fridge would be a camera module for image recognition, inventory management with FIFO, that is first in, first out, where usually more than one same item is placed into the fridge. So the items that are older needs to be used first, and that is near to the expiry date. Detection of spoiled food, detection of expiry date using camera detection as well as manually inputting into the IoT app, suggestion of healthy recipes based on the items present inside the fridge, and generating a shopping list based on items that are not present in the fridge. And also, if anything is amiss in the refrigerator, it can also alert and give notifications using the IoT app. This flowchart outlines the functionality of the fridge. When the door is opened, the camera module will detect the item present inside the fridge or items being placed or removed and recognizes it, the users can also input the user ingredient data, including their nutritional information, any food allergy, medical records, etc. And based on this and the fridge inventory, the system will suggest healthy recipes to the user. And if an item is missing, we'll let the user know that they need to order these items. The smart fridge involves 3 data processing units, that is store data processing in order to get to know what are the items present inside the fridge, a recipe data sheet processing, and a nutrient data sheet processing. This is the system architect. So the Raspberry Pi will act as a microprocessor and it will integrate with various other sensors such as temperature sensors to control the temperature within the refrigerator. The ultrasonic sensors, IR sensors, load sensors, and the camera module will act as the to item detection, inventory management, and organization. The gas sensors to detect any spoiled food present in the fridge, and the PIR motion sensors to detect any motion or spilled foods within the fridge. The IoT mobile app will also help in giving real-time access information of items present inside the fridge to the users and can can also alert and give notification in regards to if the door is left open or any items that are nearing its expiry date, and can also view the contents of the fridge within it. In conclusion, a smart fridge addresses various challenges and tackles issues such as food wastage. It is an energy efficient device, and it promotes health and nutrition as well as food safety. It is convenient and connectivity using an IoT mobile app, and it's a sustainable tool. Therefore, smart fridge is a sustainable tool that will improve the quality of life. These are the references. Thank you.
Thank you, ma'am. Sir, do you have any questions? Sir, do you have any questions? So let's move towards the next presentation. For the next presentation, I would like to call Priyanka Patel for the paper title Using Deep Neural Networks for Enhanced Visibility in Low Light Image Enhancement. I request the presenter to kindly proceed with the presentation. I think so, ma'am is facing some network issues. So let's move towards the next presentation. For the next presentation, I would like to call Dharawat Ramesh for the paper title Enhancing Healthcare Privacy, a Synergistic Approach with Federated Learning and Blockchain Integration. I request the presenter to kindly proceed with their presentation. Maybe sir is facing some network issues. Let's move towards the closing remark of the day.
Hello.
Hello, sir.
I think all 10 papers have not presented, right?
Yes, sir.
Okay, take it.
Thanks, sir. So we are moving towards the closing remark. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during this 9th version and all the previous 8 version of the conference. We'll be happy to have you in the 10th version in 2025. All the presenters will be getting their digital certificates through email within 2 working days. Further, all the papers have already forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICTCS 2024. I also thank our session chair, Professor Amar, for sharing the session. Sir, this is the token of appreciation from GR Foundation and partners for chairing the session.
Thank you very much.
Thank you, sir. Now, I request everyone to kindly turn on their cameras for a quick snapshot of the virtual conference. Thank you, everyone. Stay safe, stay connected. Let's meet you in the 10th version in 2025.
Thank you very much for giving opportunity.
Thank you,
Thanks.
sir, for your valuable time and presence. It means a lot for us.
Okay, thank you very much. Okay.